Let's look at some code to implement the state chart we just saw with the 2-button fan. In any state chart, there has to be a variable keeping the current state, cur state. And in this case, we've defined it as an enum that can be off, slow, medium, or fast. That means the system knows which state it's in simply based on the cur state variable. We want to identify constants that allow the speed to be set to values that mean something in the code instead of using magic numbers. So we've defined 4 constants for off, slow, medium, and fast, and those numbers are arbitrary. They could be changed. If fast is 25 on one model or fast is 30 on another model, the rest of the code remains the same. We initialize current state to off. That corresponds to the reset arc. And note that we're able to use the name of the state so it's more obvious what's happening in the code. There's a procedure, process states, which periodically runs from the main loop. So for example, it might run 10 times per second and processes this state machine. In general, every state machine will have a subroutine like this to process its states, and all the state machines are run periodically in part of the main loop of the software. The code switches on current state, which jumps it to the part of the code that deals with the state the system is currently in. And you can see case off is you're in the off state. And notice the comment, state S1. The reason we have a number is it makes it easy to look at it and say, oh yeah, this is the off state, and yes, we meant state 1. There's no chance for mistake here. The first line does the side effect. It says, set the speed to speed off. Then the code looks at the arc guards and decides which guards are true. If speed button is true or on-off button is true, then the current state is slow. That line of code tests the guard conditions on the output arc from off and sets cur state to a new state. The net result is, if that arc is true, then the state will change for the next time the code runs. The break is the end of handling this particular state, and you're done until the next time the process states function is called. Now we march down all the states and do pretty much the same thing. For the state slow, which is S2, we say, well, the side effect is speed slow, so you run the side effect. And in this case, there are 2 output arcs, so there's 2 if statements. The first if statement is if the speed button is true, then set the current state to medium. The second if statement is if the on-off button is true, then set the current state to off. The pattern here is that first you do the side effect, and then each outgoing arrow has an if statement that changes the state if the guard is true. Continuing with the code, if you're in state S3, which is medium speed, the side effect of actually setting the speed to medium is performed, and then the 2 outgoing arcs are checked to see if you stay in the same state, which is none of them are true, or you move to the fast state if the speed button has been pressed, or you move to the off state if the on-off button has been pressed. The last case handles fast speed, and again, you take the side effect, change the 2 arcs, and the fan turns off if the on-off button has been pressed. Finally, there's a cleanup default state that throws an error because all the cases should have been handled and this line of code should never execute.